All right, we made it. Spring 2025 final exam review. Let's get into it. Number one, arc DE has a central angle of 160 degrees. Circle O, pretend there's an O right there, has a radius of 8 centimeters. What is the length of arc AB in terms of pi? So we have the word length and arc. So this is arc length of AB, and that would be theta times 2 pi radius over 360. Or you could use pi times diameter instead of 2 pi r. So that'll be 160 times 2 pi 8 over 360. And it says that our answer needs to be in terms of pi. So we're going to put this in the calculator with everything except for the pi. All right, so we've got 160 times 2 times 8. Again, don't put pi. We're going to leave pi in the answer as the simple pi. So we get 64 over 9. So what we're going to write is 64 pi over 9. All right, and there she is. Number two. What is the total surface area of the trapezoidal prism below? So we know that total surface area is also just called surface area, and its formula is perimeter of the base times height plus the area of both bases for a prism, if I didn't say that already. So the perimeter of the trapezoid is 8. We see that 8 over here, plus 5. We see that 5 over here, plus 5, plus 5. We know that these two are the same because of these little markings. So 8 plus 5 plus 5 plus 5 is going to be 23. So the perimeter is 23. The base perimeter, base perimeter. Don't forget that's base perimeter, not just perimeter. And then the height of the prism is 14 plus 2 times base area. So base area is going to be area of a trapezoid. So we're going to use the trapezoid area formula. So 1/2 times the height of the trapezoid, not the prism height, but the trapezoid height, which is 4.8 times the bases, the lengths of the bases of the trapezoid. So one base of the trapezoid is 8, the other is 5. Okay, and then when we do that, we should get 31.2. Okay, and then when we evaluate all that together, we should get 384.4 square centimeters. Number three, which of the following sets of numbers is a Pythagorean triple? So Pythagorean triple just means that these three whole numbers fit the Pythagorean theorem, for lack of a better word. So we got 3, 4, and 5. So we're going to add the 3 squared and the 4 squared, and we're going to see if it equals 5 squared. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, which does equal 5 squared. So this is a good one. Let's try the 6, the 8, and the 10. So 6 squared plus 8 squared, we're going to see if it equals 10 squared. 6 squared is 36, 8 squared is 64, 36 plus 64 is 100, which does equal 10 squared. So that checks out. Next, we're going to try the 10, the 24, and the 27. 10 squared is 100, 24 squared is 576. And when we add those together, we get 676, which unfortunately does not equal 27 squared. You can verify that on your calculator, so that's a no. Just those first two. Number four, triangle ADE and ABC are similar. Find the value of x. All right, so since these triangles are similar, this is what you need to do. I would personally draw them separately. So we got this guy, and then we got this guy, and those are the two triangles. So I'm just going to take the bigger one and put it down here so that we can see it separately. So this would still be A, this would be B, this would be C. And the side of that bigger triangle is 28 right here. AB is 28. BC is still 2x plus 3. Okay. And I'm going to, for your sake, I guess, if you need me to, or if you would need to do this, I'm just going to white out the rest of this so you can see what I'm saying here. So, oops, I need that 15, don't I? All right, so we can genuinely compare these two triangles and write the ratio, the proportion to solve for x. So we see that AD, that 20, matches up with the 28. So this one and this one go together, just like this one and this one go together. So that's going to be our ratio, 20 to 28, 15 to 2x plus 3. So now we're going to solve the proportion. And we're going to start by cross multiplying. So 28 times 15 is 420. And then we got 20 times 2x plus 3. We're going to have to distribute the 20. So 20 times 2x is 40x. 20 times 3 is 60. Now we're going to take away 60 from both sides. So that's 40x equals, what's that, 36? 360, sorry. And then we're going to divide both sides by 40. So we end up with x equals, let's see, those zeros can cancel out. 4 goes into 36 9 times. So we get 9 here. And of course, plug 9 back in to make sure that it actually works. Okay, number next. Which of the following sets of numbers can represent the length of a triangle? So in order for it to be the length of a triangle, A plus B has to be greater than C. Not A squared plus B squared equals C squared. No. Don't square anything. Just add the two smaller sides, and if it's greater than the third side, it is a triangle. If it's not greater than the third side, it would not make a triangle. So here we'll go 4, 4, 4. Is that greater than 10? No, 8 is not greater than 10, so this would not work. Then we got 1 plus 1. Is that greater than 3? No, 2 is not greater than 3, so that wouldn't work. Then we got 1 plus 2. Is that greater than 3? It's equal to 3, but it's not greater than 3, so that wouldn't work. Then we got 4 plus 5. Is that greater than 10? No, 9 is not greater than 10. So none of these would actually work. Next. All right, quadrilateral ABCD has the following vertices. Let's graph them. Oh, determine the type of. That is supposed to say quadrilateral. I'm sorry. So quadrilateral. A is 3, 3. B is 2, -1. C is -3, -1. And D is -2, 3. All right, take a look. What does it look like to you? Well, that's not right. Let me try that again. I promise this worked earlier when I did it. Okay, just got to exaggerate it a little bit. All right, so after some trial and error, what shape does this appear to be? This is definitely a parallelogram. We can see pretty easily that the opposite sides are parallel. So these two sides have a 0 slope, so they're parallel. And then these two sides have a slope of 4, 1. So, yep, they're both parallel. All right, so parallelogram. Parallelogram. Number 7, what is the probability that a dart will hit outside the inscribed circle? All right, so we're basically trying to figure out what's the probability of the shaded region being hit. So the probability of shaded, so shaded, this part is shaded, equals the area of the shaded region over the area of the whole thing. So let's find the area of the whole thing, which is a square. Square. So the side length of this square is 12, so the area of the whole thing is 144. To find the area of the shaded region, we're going to have to find the area of the circle, which is unshaded. Circle area is pi r squared, so it's going to be pi. Now the radius is going to be half of 12, so that's 6. So that's going to be 36 pi. The area of the shaded region is going to be the square area, or the squarea, minus the circle area. All right, so that is what we're going to put up here. You can put it in your calculator to get the decimal if you want. I just didn't feel like going back and forth. And then put that over the total area. That's still not, okay, I give up. Whatever, it's fine. Doop. And then whatever you get, what decimal you get should be the answer. All right. Point 0.21. Oh, said to the nearest tenth. Sorry, 0.2. All right, next, we're trying to find the volume of this cone. Volume of the cone is 1/3 pi radius cubed squared times the height. I'm tripping. 1/3 pi r squared height. So 1/3 pi times the radius squared times the height. And I'm gonna do, you know what? I'm gonna do this by hand because why not? All right, 1/3. I'm gonna do this kind of out of order because everything's being multiplied, so we can go out of order. 1/3 of 18 is 6, so that helps. 9 squared is 81, so 81 times pi times 6. What's 81 times 6? 6 times 8 is 48. That's 46 pi. I think that's right. All right, we're gonna rock with that. Okay. Alrighty. Just out of curiosity. Yep. All right, cool. All right, so the answer is 1526.81. You can leave it like that, or gross. There we go. My goodness. All right, and then we got that answer or that answer. So in terms of pi and then decimal, it does say approximate, so that means decimal, but I put both just to get to practice. Number 9. Rectangular prism has a volume of 25 cubic feet. Find its volume if one of its dimensions was doubled, the second dimension was tripled, and the third dimension was increased to 4.5 times the original length. Okay, so here's what's happening. Here's what's happening. Stay with me. Rectangular prism. All right, so the volume is 25 cubic feet. All right, now the new one is bigger. You know what? That was dumb. Was it dumb? But was it dumb? Yeah, it kind of was. All right, so the new one of its dimensions is doubled. Okay, this isn't my best work, but it's fine. All right, so one of its dimensions is doubled. So this one is multiplied by 2. The second one is tripled. This one, let's say, is multiplied by 3, and then this one is multiplied by 4.5. So all the dimensions are increased by that much. Now, I know when we studied this, I was like, hey, just raise it to the third power, just raise the scale factor to the third power. This one has 3 different scale factors. So this is what you need to do. We don't know the original length, width, and height, but we do know the original volume. So since it's length times width times height to get the volume, take the original volume and multiply it by these different changes over here. And that will give you your new volume. Ta-da. All right, number 10, calculate the value of x round to the nearest tenth. Ladies and gentlemen, this is geometric mean. You didn't ask, but I'm telling you. That's an M, sorry. Geometric mean. So the way we do this is going to be 16 over x equals x over 9. Okay, so again, you do this over this equals this over this. That's how you always set it up. All right, now we're just going to solve for x. So 16 times 9 is 144. X times x is x squared. And when we take the square root of both sides, we get x equals 12. All right, number 11. Standard six-sided die is rolled and the coin is flipped. I smell probability. Yes. What is the probability that the die will land on a number greater than 3 and the coin will land on tails? So we went, what is the probability that the die will land on a number greater than 3 and the coin will land on tails? All right, so the probability of landing on a number greater than 3. So a number cube or a die, well, you know what? I'm going to be a little lazy. Yeah, that wasn't great. That's not in the middle, was it? That was not in the middle. Mm-mm. Okay, I tried my best. So pretend that's obviously the 6 sides of a die, and we want numbers greater than 3. So 4 is greater than 3, 5 is greater than 3, 6 is greater than 3. So 3 of them are greater than 3. How many total sides are there? There are 6. Now for tails, on a coin, there's heads and there's tails. So that's 1/2. 1 tails out of 2 sides altogether. And then we're just going to multiply. So 3 times 1, 6 times 2, and then we can simplify this by dividing by 3. And so we get 1 over 4. That's the fraction. We could write it as a decimal, or we could write it as a percent. All right, number 12. Find the measure of angle BCE. BCE, this angle right there. All right, there's nothing in BCE, which means we're going to have to use another angle to figure it out. So let's see what we're working with. We have this angle here and this angle here. Lucky for us, these are alternate interior angles. So it's part equals part. And now let's solve. So we get 2 for x, but they don't just want x. We have to plug it back in. to figure out the missing angle over there. So I'm going to plug it back in right here. All right, so that angle is 19. That's a right angle. So we know that the right angle is 90 degrees. If we take away 19, that'll give us 71 degrees. So this angle here is 19 degrees. This angle here is 71 degrees. So they can add up to 90. So there you go. Number next. Write the standard equation of a circle with a given center of 4, -7. All right. I'll write the standard form first. Oh, that's not right. That's right. All right, so that's our h, that's our k, that's our r. So that's going to be x minus 4 squared plus y minus -7 squared equals 10 squared. Let's clean it up a little bit. This part is fine. And you know when you have a double negative like that, it's really positive. So we're going to change that to y plus 7 squared, and 100 equals 10 squared. So voila. On to the next. An oatmeal container is cylindrical in shape, 10 inches tall with a radius of 4 inches. So let me just do a nice little sketchy sketch. So it has a radius of 4 inches and it's 10 inches tall. Miss Jones had cooked breakfast for her family for a week. The oatmeal filled the container to, after she had done that, the depth was down to 5 inches. So the whole thing is 10 inches tall. So let me move this over. Okay, and then after she had fed her family, it went down halfway to 5 inches. All right, what's the approximate volume of the oatmeal remaining in the container? So we just want the volume of the 5-inch high oatmeal. All right, so volume of a can of a cylinder is pi r squared h. I lied to you. No, volume. We're doing volume. Yeah, I was right. So the area of the base times the height. So that's going to be pi radius squared times the height. Let's see, that's pi times 16 times 5. 16 times 5 is what's that? 80. That's 80 pi. All right, so we could leave it like that. It did say approximate. Oh, wait, hold up. I missed something. No, I did not. Okay, so we could write it like that, but since it did say approximate, let's change it to a decimal. Oh, all right. Oh, goodness. 80 pi, 80 pi. Okay, 251.33. That'll be cubic inches. All right, number next. What's the value of x? There's a mistake on this one. Let's make this the square root of 2. So this is a special right triangle. This is a 45, 45, 90 triangle. So we're going to use the 45, 45, 90 rules, which state that the hypotenuse divided by the square root of 2 would equal one of the legs. So the hypotenuse is 12 square root of 2. We're going to divide that by the square root of 2, and that'll give us 12. Number 16. While sitting beside a pool one day, you spot a coin at the bottom of the pool. The pool is 12 feet deep, and the angle between the top of the water and the coin is 20 degrees. How far is the coin from along the bottom of the pool? All right, so we have this angle of depression. It didn't say that, but that's what it described. The pool is 12 feet deep, and you're trying to figure out what the distances like horizontally between you and the coin. So I'm just going to put this little dotted line down here because this is the bottom of the pool. That's what we're trying to figure out. So the x that I put on top is equal to the dotted line, the length of the dotted line on bottom. All right, so let's go ahead and label this thing. This is a trig problem since it's angle of depression. That would be opposite because this would be theta. This would be adjacent. Hypotenuse is blank, leave it alone. Opposite and adjacent is tangent. Opposite, adjacent, tangent. Opposite, adjacent, tangent. So tangent theta is 20, opposite is 12, adjacent is x. Now we just got to solve for x. I'm actually going to move this because we're going to need a little bit more space. All right. The first thing that I see is we got to solve for x. X is at the bottom. Rather, the first thing I see is a fraction. So I'm going to multiply by the denominator to get rid of the fraction. So now we have x times tangent 20 equals 12 because those x's canceled out. And the x is still not alone over here. So we're going to have to get rid of the tangent 20. And that's going to cancel. So now we're left with x equals whatever that's going to be. So in our calculators, we're going to put this. 12 divided by tangent 20. Please make sure your calculator is in degree mode. And we get 32.97. Okay, I didn't say where to round, so we're going to round it there. All right, moving on to number 17. Which transformation best describes the movement of the figure from A to B to C? All right, so from A to B, this is a reflection. It flips. And then from B to C, it rotates. Number 18. O is the center of a circle below, and P is the point of tangency. If the measure of angle PTO is 50 degrees, what is the measure of POT? All right, well, if this is a point of tangency, that means this is 90 degrees. So we can do 90 minus 50 and get 40 degrees. So that angle would be 40 degrees. If you don't like that, you can use the 180 rule. 180 minus 90 plus 50. You're still going to get 40 because 90 is half of 180. Number 19. Find the value of x. Since those two lines are parallel, we know that these are similar triangles. And since we're using these sides, we can set up a proportion. So 8 over 4 equals, so that was 8 over 4. So we got to do 2x minus 10 on top and then 5 at the bottom. All right, and then just simplify and solve. Cross multiply and solve. So we got 8 times 5, which is 40. Then we got 4 times 2x minus 10. We can distribute the 4. So that would be 8x minus 40 equals 40. We can add this 40 to both sides. That'll give us 8x equals 80. Then divide both sides by 8. And that gives us x equals 10. Number 20, what's the angle of elevation? So this is our angle of elevation right here. All right, so since that's theta, that means this is opposite. This is adjacent. Hypotenuse is blank, so we can ignore it. Again, we're dealing with tangent, opposite, adjacent, tangent, opposite, adjacent, tangent. All right, so theta is just theta. We don't know. That's what we're trying to figure out. Opposite is 6 and adjacent is 9.7. So what do we do when the x or the missing value is not in the fraction? We're going to have to use the inverse of tangent. So that's going to be tangent inverse and then put this, and that will swap those. I told you before you cannot separate theta from the trig ratio unless they get a proper divorce. That would be the inverse. So inverse is the only way you can separate them. All right, put that in your calculator. So we get 31.74. Given the triangle below, calculate the length of the side. All right, I'm looking at this. This is a 30, 60, 90 triangle. So we're going to use 30, 60, 90 rules. Again, this is a special right triangle. The rules state that if you take the short leg and multiply it by the square root of 3, that's going to equal the long leg. Why do I care about that? Because that's what x is. 5 is the short leg. This is the long leg. This is the hypotenuse. We don't really care about the hypotenuse. All right. You know what? I'm going to put a box. No, I'm not going to put a box. I'm just going to, oh no, go back. I'm going to get rid of this because I don't want y'all to think that's a fraction. Yeah, okay, whatever. All right, so the 5 is the short, multiply that by the square root of 3. You can leave it like that, honestly, or you can put it in decimal form by multiplying it out. So 5 times the square root of 3 is 8.66. So either way will work. Number 22, if RT is this and US is this, find X. All right, good news. This is part equals part because the diagonals of a rectangle are equal. Okay, and now we just have to solve for X. Done. Number 23, what's the lateral surface area of the cylinder? Right cylinder is just a cylinder that's perpendicular to its base, I guess you could say. So lateral surface area is perimeter of the base times the height. And since this is a cylinder, it has a circular base. Oops. Perimeter of a circle is just the circumference, so it's going to be 2 pi r, or you could use pi times diameter times the height. It doesn't really matter. Just you can use the formula in the formula chart, which I think is 2 pi r, whatever works for you. It's the same thing regardless. All right, diameter is 12, height of the cylinder is 8. I know the cylinder is laying down. That does not change what the height is. Just because you lay down, your height does not change. I don't know how many times I got to say that, but y'all got to remember. All right, so 96 pi is the lateral surface area. We could just leave it like that, or, so that's 96 pi square centimeters, or we can change it to decimal form, 301.59, 301.59 square centimeters. All right, so either of those would work. Number 24. A circle is, I am so sorry, this is jacked up from the crack up. The circle center on point D, points A, B, and C lie on the circumference. Ignore this statement. Find the measure of angle ABC. All right, so this is, I'm just write it down. So an inscribed angle is going to equal half the central angle that it matches up with. Okay, so inscribed angle. So the inscribed angle is ABC. And then the central angle is ADC, which was 150 degrees. Okay, half 150 degrees is 75 degrees, and that is it. Number 25, the length of the radius of the circle is 8 centimeters. So I'm gonna just draw a picture. I'm a visual type of gal. All right, so radius is 8. That was so weird. Try that again. Okay, and then the sector is 50 degrees, so this would be the sector. So all of that. That's a pizza slice we need. And we want an area of a sector. So that's going to be 50. Oh, so we write the formula. Theta times the area of a square over 360. All right, so that'll be 50 degrees times pi radius squared over 360. And it says best estimate, so we could put it in we need to put it in decimal form. But if we put it in terms of pi, you put in everything in the calculator except for pi. So it would be that, or you could change it to decimal form, which is what the problem called for. So, yeah. All right.